This question comes from a viewer who asked, what if someone falls into a black hole just as their exact copy is made on the event horizon of the black hole? Would there be two copies of them? This is a fun question because it takes something that's already weird, quantum physics, and makes it even weirder. So let's have a look. We're going to need some background information first. First of all, quantum physics forbids the cloning of information. No, seriously, it really does. In quantum mechanics, you can clone anything except information. You can make a copy of a quantum state, but due to the uncertainty principle, you cannot copy the information contained in it. The best you can do is put the information back into a bigger box with many possible states. And then you have a 1/2 chance that it S in this box and a 1/2 chance that it S in that box. If you want more certainty, you have to increase the size of the box, but then your copy becomes less and less similar to the original. If you want to copy information perfectly, you have to go down to Planck scale distances where quantum effects become significant. And once you've done that, you can't measure anything anymore because, well, your Planck length. I don't know what that means, but I suspect it doesn't involve photo albums. Now, why is that so? One reason is that it's difficult to share information. Let's say you have a quantum particle that is spin up. That's a pure state of information. It contains a lot of information. Now you want to share this information with a friend. You throw the particle to him, but he only catches it sometimes. When he catches it, we call this a measurement. If he measures spin up, you tell him the information is spin up, but he only tells you back that he measured something, not whether it was spin up or spin down. The information is lost. This happens because whenever you measure a quantum particle, you always get a random result. The other reason is that when you copy something at Planck scale, you change it. Think of it like copying a very detailed drawing. The smallest detail you can draw is a straight line. So if you want to copy a picture that contains curved lines, you have to thicken the lines in order to copy them. This thickening is necessary to make the copy distinguishable from the original. And the same happens for quantum information. You have to add noise when you copy it. This noise is necessary because otherwise it would be impossible to tell apart the copy from the original. Okay, but what if you were that information? Then it wouldn't be a problem, right? Well, yes, but no. There's also a third reason why quantum physics doesn't allow the cloning of information, and that's relativity. You see, time is relative, and this means that the notion of now is relative. You can't say what is happening over there in some other system without telling us what is happening here. What's now for you might not be now for the other person. There's always a reference frame. And if you want to talk about the cloning of information, you have to ask what reference frame do you mean by now? Or put differently, you can only talk about the cloning of information if you have information about the reference frames of the two copies. And that information can't be copied. That's a theorem. It's called the no-cloning theorem. It's basically impossible. But your question is about a special situation, one that maybe works around all these problems, and that's a black hole. A black hole is something very special because there is a place around it where nothing can get out. It's the event horizon. If you cross the event horizon, you can never come out again. Not that you could ever come back and tell us about it, but you can also not send messages back because messages are information, and information can't be sent out of a black hole. So now imagine you cross the event horizon of a black hole, and just as you do, someone outside the black hole makes a perfect copy of you. We'll call this copy you prime. How does it go? Well, as far as you're concerned, nothing goes because you're going into the black hole. For U prime, on the other hand, everything goes because U prime is standing still. However, since you fell into the black hole, U prime can never know what happened to you. U prime will inevitably also cross the event horizon and fall into the black hole, but by then, you are long gone. So we have a situation where you fall into the black hole and your copy stays outside. But then U prime falls in too, and suddenly you both fall into the black hole. Does that mean that information is cloned? Yes and no. In some sense, it's cloned because your copy exists outside. In another sense, it's not cloned because whatever happens to the copy must happen to you too. But that doesn't make any sense because then either you're cloned or you aren't. But the issue is that the black hole prevents us from telling which case it is. In the case that you are cloned, you prime would be outside waiting for you until it falls into the black hole itself. But you never know that because you're inside the black hole and can't communicate. And if you never know it, it doesn't make any difference. In the end, the information gets destroyed in the black hole regardless of whether you're cloned or not. In summary, you can't clone information. You can clone stuff, but you can't clone information. And even if you fall into a black hole, you can't clone information. At best, you can make a copy of yourself, but that copy will fall into the black hole too. And at worst, the information gets destroyed in the black hole. By the way, I sometimes wonder whether that's the origin of all the conspiracy theories surrounding black holes. Maybe some people think they could clone themselves and live forever on some copies and keep track of the originals, and it would work because black holes don't exist. Just kidding, black holes do exist. I find questions like this so interesting because they take knowledge that physicists have worked decades to acquire and package it into a little scenario. And then, wham, within a few minutes, someone gets an intuitive understanding of some complicated concepts. And then that someone often has more questions, and this spreads knowledge further. And that's why I love working together with Brilliant, whose mission is to help you learn science in the easiest and most engaging way possible. They offer courses on a large variety of topics in science, computer science, and mathematics. All their courses have interactive visualizations and come with follow-up questions. Some even have executable Python scripts or videos with little demonstration experiments. Whether you want to know more about large language models or quantum computing, want to learn coding in Python, or know how computer memory works, Brilliant has you covered, and they're adding new courses each month. So go and check this out. I'm sure you'll find something that you'll love learning. Thanks for watching. See you tomorrow.